Hello everyone, welcome back to my channel. I am Soumya here and today we will be solving the second question of the Google challenge. So this question that we will be solving today was also similar to the question that was asked in the Google's interview, and today's question is jumping numbers, which is also tagged as POTD of GFG. So first let's understand the question. Before moving to the question, I just wanted to clear one thing. The 60 days challenge that we started at the first, it is the continuation of that challenge only. In the last 30 days, we had to do the questions that were asked in the different top companies' interviews. So the first company that we picked is Google. So don't get confused. It's not a different challenge. It's actually the continuation of the previous 60 days challenge. Okay, so now let's understand the question. So today we will be solving this question, and the question is jumping numbers. So first, let's understand what is jumping numbers. A jumping number is a number whose adjacent digits differ by exactly 1. Right? All the single digit numbers are considered as jumping numbers. This also we need to keep in mind. So if we take an example, 7 is a single digit number, so it's a jumping number. Okay. For 8986, we can see 9 minus 8 is 1. 8 minus 9, the absolute of this is 1. 7 minus 8, the absolute again is 1. So the difference between the adjacent digits should be 1, and if it is possible for each and every adjacent digits in a number, then the whole number is jumping numbers. So moving on to the question, we are given a positive number x and we have to find the largest jumping number which is smaller than or equal to x. So what thoughts comes to our mind is to check each and every number till x if it is a jumping number, and store them somewhere and return the maximum among them, right? Yeah. So moving on to the example, if we see here, the x is given 10 and the output is 10 itself. Why? Because 10 itself is a jumping number. 1 minus 0, the difference is 1. So 10 is the largest jumping number possible for x is equals to 10. Okay, moving on to the brute force approach. Brute force approach is like the silliest of solution that can come to your mind. Right? I pasted the question here so we don't get confused. And also the constants and time complexity. Today we'll also be focusing on the constant, how to guess what time complexity we have to solve the question in by seeing the constant. Okay, so for brute force approach, I was already practicing it, so I wrote it for you. The first and the silliest approach that came to our mind was to traverse all the digits till x, right? And check if the and what we have to check if the number is jumping number or not. Return the maximum among them. So for this example, if we see, right, for this one, then for x is equals to 10, output is 10 itself. Why? Because absolute of 1 minus 0 is equals to 1. So hence it's proved that it is a jumping number. So the approach that we will be following is, we'll start from I is equals to, you can say 0, 1, let's take it 0. So from 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 till 10. All these are jumping numbers? Yeah. Here we read in the question, it was given that all the single digit is considered as jumping number. Got it? So all the single digit is a jumping number. 10 is also a jumping number since 1 minus. So the greatest among all the jumping number is 10. It will be our answer. Okay. Now we have to code this. Let's move on to the coding part. So there will be a function int check, we can say, where int x no, not x, will just consider it I, that we will be passing. Here we will be checking, check if I is a jumping number, and the main function will be int jumping, let's write it, and the input is x. So for the brute force approach, first of all, the base case. What's the base case for this solution? Any hint? Okay, for base case, since it was already given in the question that all the single digit is a jumping number, that will be our base case. So if x is less than equal to 9, let's also include 10, because again 10 is also a jumping number. So less than equal to 10, return x, right? Else what we have to do? We have to traverse till x and then check all the possible jumping numbers till x and store them somewhere and then return the maximum among them. Else int I is equals to 0, I less than equal to x, I plus plus. Let us see the constant. Okay, the constant here is given that x will not be 0, x will be greater than equal to 1. So let's not include 0. Let's not include 0. Let's start it from 1. Int I is equals to 1, I less than equal to x, I plus plus. So here we'll be checking for each check I. Then what we have to do? We have to check if, let's introduce answer is equals to 0. Check if answer is equals to max of answer comma I, and then return answer, right? Now let's complete the check function. Here you have two ways to solve the check function. Two ways we have. First is convert the integer into a string and then just use 2 pointers. So either string then 2 pointer, right? Or just let it be in integer, then use n equals to n divided by 10 for 2 pointer. That's what we do. I'll go with the string part. String x is equals to string I. Now what I'll do, int n is equals to x dot length, right? Int I is equals to 0. Let's take it L, sorry, and R is equals to 1, while L is less than R, and one more condition we are leaving, and R is less than N. Then what we have to do, we have to check adjacent digits if its difference is 1. If not, then we have to just return it 0 or false, whatever. So if x of L, how to convert the char into char to int, what we do is s of I, the char part, minus 0. This is how you convert char, a character to integer. So here we'll do the same. Minus, also here let's include absolute, minus x of R minus 0. Right. What it should be? It should be equal to 1. Should be exact 1. And here will, if not equal to, let's see, not equal to, then just return 0. Else, at last, we should return 1. Sorry, we should also increase L and R. Here we'll also increase L plus plus and R plus plus. Okay, so I think we are done with the brute force approach. So what's the brute force approach? From here, let's see the base case. All the single digit is a jumping number. Then, if not a single digit, then check for all digits till x, then return maximum among them, and here is the check function. So let's code it. Okay, let's first discuss the time complexity, then we'll move on to the coding part. So here I already wrote the time complexity. I'll tell you why it's big O of n log n. So guys, we are running a loop, and for every ith integer we are checking it if it is jumping number or not. So log n is for check function and n is for traversing till x, and we have to multiply it. So big O of n log n. Right? Now let's go to the constraint and see if this code, like this brute force code, will work or not. Okay, we have been directly given by the question itself that the expected time complexity here is big O of, and you can say okay, whatever, it should be linear. big O of n. But our time complexity is big O of n log n. So it will be greater than big O of n, hence it won't work for some cases. Also, here in this question, it was directly given by the question itself that this time complexity is needed. But sometimes we are just given constraint and not the time complexity. So always think that we have to solve a question whose time should take less than equal to 10 to the power 8. Okay. So here, since we can see x is less than equal to 10 to the power 9. So here big O of k can, like you can say x. Big O of x can still work, right? But big O of x log x will not work, because big O of x is 10 to the power 9 in the worst case. So big O of x log x will be always greater than that. And the best, you can say time complexity is 10 to the power 8. So we can't afford this. So we'll have only two options left, either to solve the question in big O of k, you can say x, or big O of log x. Right? So let's first code it and see if our brute force approach is correct or not. Then we'll move on to the better approach with the better time complexity. The base case is if x is less than equal to 10, return x, right? Else just make a loop from I is equals to 1, I less than x plus I plus plus, check if check I. Then answer is equals to max of answer comma I, right? Let's declare answer first and then return answer. We also have to, let's take it bool, make the check function int I, have to take string x is equals to string I, to string I. Now int n is equals to x dot length and left point, we'll have to take two pointer, left pointer and the right pointer. Now while loop where L is less than R, sorry, not equal to, because we have to check the adjacent, check that the difference between the adjacent digit is 1 and R is less than N. This condition should also satisfy, so the R pointer doesn't go out of bound. And to check if the difference should be in absolute. Now again bracket, let's convert the character into integer. So LPSR minus, let's take this as, move from here with this. Okay, this is not equal to 1, then return false, else return true. Right? Think we are done with it. Yeah, the basic test case did run. Okay, here we can see the time limit has been exceeded because we know that our solution takes big O of n log n time, and the solution that question requires should be in the time complexity under big O of n, as it was mentioned in the question also. Here time complexity should be linear, that is big O of n. And also through the constraints we can see. Okay, moving on to the better approach. We all know that the single digit is a jumping number. So let's write all the single digit. Now, so here we'll be using BFS for it. So here I have written all the single digit number. Now for 1, if we take the number leading with 1 in 2 digit, that is a jumping number. So I can say 12 is a jumping number because 2 minus 1 is 1. 10 is also a jumping number, we know it. For 2, I think 21 is a jumping number, and 23. So for every you can say single digit, there are 2 possibilities, right? For 3 it is 32 and 34. For 4 it is 43 and 45. For 5 it is 54 and 56. And for 6 it is 65 and 67. For 7 it is 76 and 78. And for 8 it is 87 and 89. And for 9 we have you can say 98, and other number, no, other number doesn't exist for 9, because if we say 100 then no, right? So to calculate this 2 sets for every, you can say, digits, let's derive a formula. So a formula for it being, you can say, number into 10 plus last digit plus minus 1, right? This is the formula for generating these pairs for every number. So with this formula we will be able to create a whole tree, that is for 1, let's take an example 1. So for 1 it's 1, 2 and 10, and then again for 12 we can say 1, 2, 1 and 1, 2, 3, and for 10 we can say 1, 0, 1. It's only 1, 0, 1 here. Then again we can extend this. So there are 2 exceptions. When we see using this formula, there are 2 exceptions that will come. 2 exceptions. One is when last digit is 9. Last digit is 9. And second is when it is 0. And except these 2 exception, I think it works for every digit. Now also let's take another example. We can take 2 as an example, then 21 and 23, and then again for 21 if we say, then 210 and 212, and for 23 it's 232 and 234, and then again it will just move on. Let's see if this formula works or not. Formula was num into 10 plus last digit plus minus 1. For 2, if we take 2 into 10 plus, what is the last digit? Here we can see there is only one digit, so that will only be considered as last. So it will be 2 plus minus 1, then 20 plus 2 plus minus 1, then what will be 22 plus minus 1, so it will be like 21 and 23. Here we got it. Again for 21 and 23 we consider, then 21 into 10 plus last digit is 1, and again plus minus 1, then we can say 210 plus 1 plus minus 1, then 1 plus minus 1, then it will be 212 and 210. Okay, here, right? So I think the formula that we derived is correct. So using this formula we will be deriving the whole tree. Here we got to know some conditions, that every node will have 2 neighbors, you can say child, right? We will do BFS or DFS with every single digit. We'll start with every single digit, and for 2 exceptions, that is 9 and 0. For 9 will not take plus 1 wala case, will only take, will not take this, will only take minus 1 case, and for this it will be opposite, only take plus 1 case. Plus 1 and minus 1, what we're talking about? We're talking about the formula num into 10 plus last digit plus minus 1. We are talking about this. First is the main function, that is int jumping, whatever you can say. What we are given? We are given x. So for this, let's write the base case first. If x is less than equal to 10, return x. It will be same, base case will be same. Else int answer is equals to 0, go for loop, and I is equals to 0, I less than x, right, less than equal to x, we take 1, sorry, I plus plus, and for every digit we will be calling BFS function. Also answer, and then return answer, right? Now we have to write this BFS function, void BFS int x int node comma int answer. Whenever we do breadth first search, we use Q data structures. So let's use Q data structure here also. Let's store the node, because single digit is also a jumping number, so we have to include that into the tree too. As we have seen that for 1 we'll be making tree something like this, so 1 is also. So we have pushed it into the queue. Now while queue is not empty, we'll go into the loop and take the front one. Num is equals to, now our further node will be related to the previous node, so we'll replace the node with queue dot front, right, and then keep popping it. If node is less than equal to x, if node is less than equal to x, then we'll continue to make another node with like using the same formula that we discussed earlier. Int last is equals to node divided by 10. So there were two exception case of the last digit being 9 or 0. So here if it is 9, then we will not be including the plus 1, right? So we will only push the minus part for 9. So here's the condition what we are checking, that if the last digit is not 9, then what we will be pushing? We will be pushing the opposite that satisfies for 9. So it is the plus part. So q dot push node into 10 plus last plus 1, right? And else if last not equal to 0, then we have to push the minus 1. Q dot push node into 10 plus last minus 1. Okay, and then we'll also have to include our answer. We should include in top, where we'll store our answer comma note, right? Because we have to include the single digit also, so in our answer. So here we are storing it before making the like improvement. I think that's it. Let's consider x as 3. Okay, we can consider 33, right? So the output will be 32, right? The closest jumping number to 33 is 32. Yes. So now we'll see, does the base case satisfies? No. X is actually greater than 10, so no. So we'll go into the loop, and the BFS will be called for 1. So let's go for 1, and now we have 1 together. So in node we have 1 here. Q is now empty. Now 1 is less than equal to 33. Yes, 1 is less than equal to 33. Then answer is equals to max. So answer is equals to max of answer. The answer was 0, then 0 comma 1, it's 1. Now, is the last digit 9 or 0? No. Then both will get, like both if case will be running. Sorry, so here it will not be else. Both if case should run. Then in Q will have, you can say 10 and 12. We calculated it earlier. So 10 and 12. Right. Now we'll go again into the node. So node will be now 10. 10 is less than equal to 33. Yes. So again it will go inside. Answer will be updated to 10. 10. And Ulti will have 10 here. In 10, the last digit is 0. So, last digit is 0. So, this if else case will not run. Only this will run. That is, only plus case will be included. So, here will get included 101. Now, this has been popped up. Now again we'll go into the queue. Node will take the front. Now front is 12. Here it will get popped up. And is 12 is less than equal to 33? Yes. Then it will get in, and again it will be updated to 12. And the last node here is now 2. So both will get run, and it will include 1, 2, 1 and 1, 2, 3. Right? 101. Is 101 less than 33? Less than 33? No. So now it's over. We have in answer 12. Right? So let's now get back to our main function. Here our answer is now 12. Now again it will get run to 2. I should be 2. So I first it was 1, then it will get 2. For 2 we'll see again the same thing will run, and for 2 it since here it was made like this. Right? For 2 it will be like this. And again here the maximum for 2 will be stored as 23. Then again for 3 it will run, and for 3 it will be 32 and 34. So here we'll see the 34 will get exceed by x. So 32 will be the answer here. Right? And again, okay, so here is the case. No, we don't have to go further from 32. So let's also include here 9. So every time after 3 when it will go, then our answer will only have 32. Because for 4 we can see it's a 43. 43 is always greater than 33. So it won't cross this if function. Before coding, let's also discuss the time complexity. It's like the number of nodes that you are taking will be the time complexity. But here, we are not making nodes for all the numbers. We are not. You see, it's like only till 9. And here also we are taking, if we are taking 3, then we are building 32, 33. Here we are only jumping to the numbers that are actually the jumping numbers directly. So it's like you're not going and searching the number, you are just dropping the numbers that are the jumping numbers, less than big O of n, right? We are not traversing till n. So the time complexity will be big O of log n. Space complexity will be same, because in space complexity also we are only storing the numbers that are the jumping numbers. So let's search for we'll be creating numbers. We'll be creating like we'll be creating trees for all the single digits, right? So we'll only be taking single digits. BFS for x comma I comma answer, and here we'll return our answer. Now let's make our BFS function. Here also we'll use long BFS. Let's keep the answer as long. So you have to return long answer. Here will be int. Okay, x is also long. Sorry, long x. For I, let's take it as note. Okay, we'll be making q and push our node in it. Let's take all of them as long. Why to mess up with this? Now, while not q dot empty, not q dot empty, we'll take node is equals to q dot front, q dot pop. We'll have to check if node is less than equal to x, then only enter this region. Answer is equals to max of answer comma node. Extract the last digit is equals to node modulo 10. If last is not equal to 9, then what we have to do, for 9 we don't take the plus case, so only the minus case will be mentioned here. So node is equals to, sorry, q dot push node into 10 plus last plus 1, right? And if last is not equal to 0, then q dot push node into 10 plus last minus 1. Okay, done. Why is it like this? Oh, we are taking 0. Again. Why is it like this? X is less than 10, then only we are returning x. What's the problem here? Is the answer like always being 0? Let's include and see. Okay. Oh my god. This was getting guys, because every time it was taking answer is equals to 0, so our answer was coming 0. Okay, finally we did this question, guys. We did the second question today. I'll try to keep up with the pace and keep posting the questions as soon as possible, the solution of the video solution of the question as soon as possible. Till then, you please don't forget to do the questions or attempt the question from the sheet that I gave you. You will find the sheets link in the description below, so you can go through that sheet and solve all the questions under the in Google interview page, and that will help you a lot while preparing for the Google's interview. Okay, so see you in the next video. Don't forget to like, comment and subscribe.